Cool. Um, my name is Joe Barth. I am the AZUG chapter leader, Arizona SQL Server Users Group chapter leader for the Phoenix-based, Tempe-based user group. We focus on SQL Server and business intelligence and data analytics. So we're really excited about what's happening in the community. Here's a little bit about PASS. PASS is a professional association of SQL Server. Now through the year, a Passion Award is given to annually to a volunteer who demonstrates exceptional dedication and enthusiasm for the PASS community. So please submit your nominations. It really makes people feel like they're doing something and accomplishing a goal with PASS. And a lot of people do a lot of things. So it's really important to make your voice heard on that. PASS Summit. I am going to PASS Summit this year, and I know a lot of people from like International Cruise Excursions going. I know we have other people in the group that like to head out to PASS Summit. What is PASS Summit? If you've ever been to a SQL Saturday, it's SQL Saturday, but 3 days worth of SQL Saturday, and also the best of the best in SQL Server and data analytics, and you get to see MVPs like John presenting here. He's an MVP. You get to see the best and the brightest of SQL Server that has to offer. Also, there's networking events. It obviously is just not talks every hour or every hour and a half. It's networking events, ways to network with other DBA developers, BAs, and talk about solutioning. And then also, checking out the vendors and what is new for your company. So don't forget, reach out to me for the passcode. I do have that, and you guys can use a passcode for $150 off the registration. I know it's kind of up there and expensive because it's getting closer. It's the end of October timeframe. So PASS BA Day. Let's see, dude. It's October 3rd. So it's in October. It's, I think, San Diego. Let's see. San Diego, yes. So for limited time, you got a special going on. So it's good. It's two talks about data science in a world of big data, telling compelling stories using data to achieve business goals. So, SQL's PASS as an association is trying to broaden its horizons and do more outside of just being, SQL Server, getting also data science and big world concepts in there. So it's really cool what the International Association is doing as a whole. So, there are elections that are held, and these are the people that make PASS what it is today. They do a lot of different governances. As you can see, there are elections going on for the different regions. So please be heard and vote for those August 16th through the 25th. So it's actually right now. So you got to get in by the 25th. So please go out there and vote. They're looking for people that have, been a part of the association for a while now, and but also that have a vision for what the future is going to happen, what we're trying to accomplish here in the end goal. So influence, skilled leaders, strong communicators. Moving on, it's definitely a role. I know Amy Lewis was a passport mentor, so really, it's a great way to help out the community. And also go to, the pass.org site, but as well, if you have any ideas, you can send them to the governance at pass.org. We also do have virtual chapters, kind of like what we're doing now, but obviously more, and kind of that's what they do every time they meet, fashion. So the Global Italian, or healthcare, performance, you have everything, out there. So it's not just SQL Server, it's not just DBA, it's not just developer, it's everything. So if you have the ability to get on and go out and learn more, do so. Please reach out to these virtual chapters. And that's on the pass.org site. Like I said before, they've revamped the site and it's looking really cool. They redid ours and we got the arizona.pass.org site with the new skin on it. So that's really cool. So like I mentioned before, SQL Saturdays. What is SQL Saturday? It's a full day of training, hour and a half sessions on varied topics, ranging from DBA, developer, BA, women in technology talks, There's, usually there's not a focus, but we are having one come up in September, and it's focused on business intelligence. It'll be great. We have accepted our speakers. We're going to send out the schedule here in the next week. Really exciting because it is a focused SQL Saturday. So we're accepting a limited amount of attendees, 150. So please sign up. We only have probably about 40 spots left. So if you have the chance, it's a Saturday, obviously. We are not doing pre-cons, but we are having the Saturday event, from 8:30. We sign in, sign-ups at 7:30, but from 8:30 to 4:30 all day long, great speakers, great talks on different aspects of the business intelligence, within SQL Server and within the database realm. Yeah, so sign up as soon as you can and watch out for emails about the schedule and get ready to do that. We encourage everybody to pay the $10 for lunch so we can have a really nice one as well. And then let us know if you're not going to make it. That's one of the biggest things is we want to make sure that place is packed. It's at Galvanize in downtown Phoenix, which is really cool new venue, hip new venue that does entrepreneurship, startups location. Also, they do a lot of new advanced technology training. I know they have a bunch of different courses, which are really cool. Actually, Chris Huey, the guy who set it up, is going to do a Python class at the SQL Saturday. So check out Galvanize. It's really cool. It's really a nice place. And I went down there just last week to talk shop about the SQL Saturday, and I got to meet his boss, and I got to meet more people, and it's really exciting. So, not just Phoenix has a SQL Saturday, so it's all over the country, all over the world. So please look out for them. Please understand where they are and try to make it out to a couple different ones. There's a lot of learning, a lot of teaching to go on, and that's how we do it. And it's usually free. Maybe they charge for lunch, but other than that, it's your time and to have fun, and then also maybe win a raffle at the end. So, in ending, as far as my slides, always get involved. Let me know, or let any of the user group members know. Sean, Adam, Ram, if you guys want to volunteer, let the group know that you want to help out. We definitely had a good participation now with one of our members have taken over the social media a little bit, and so that's great. We're getting our word out through Twitter and LinkedIn, and we're still using Meetup, so we're still getting a good amount of people at our meetings, which is crucial to keeping the group going. So really excited about the future and what it brings. So without further ado, I'm going to hand over the reins to Jonathan. Let's see. I go ahead and cancel that out. Stop sharing. And then I think I will let him present to everyone, or maybe just I can do it. And then this is Jonathan from SQL Skills. He is SQL Skills is owned by Paul Randall, and we reached out to him actually 2 years ago, and we just recently had Tim Radney on. So we're really excited for the participation that SQL Skills has given us with helping in our user group and the talks they've given, and really excited for Jonathan here to talk about different aspects of working in a DBA realm on deadlocking. So I'm really excited to hear what he has to say. And he is a SQL Server MVP. He is also a principal consultant at SQL Skills. So Jonathan, I'll let you take it over. Guys, give me a wave that you can see his presentation.
Can they hear me?
So Ram, stand up if you can hear him.
Okay,
yeah,
so
he can hear you.
So this is what I call deadlocking for mere mortals. It's I love working with deadlocks. I learned to troubleshoot them in the SQL 2000 timeframe, where they were much more difficult to have to go through analyzing and figuring out. And that knowledge is kind of carried forward through 2005, 2008, all the way up to 2016 and 17. And I found that a lot of people have problems with troubleshooting deadlocks. So I kind of went through the steps and figured out the key information that I think somebody would need, and that's what this session is basically all about. So as it was mentioned, I do work for Paul and Kimberly at SQL Skills, also with Glenn, Aaron, and Tim. And we do everything from consulting work to instructor-led training events, online training with Pluralsight, and speaking at conferences. And so this is what I always say is my yay me slide. The most important thing on this slide, though, is my email address, jonathan@sqlskills.com. If you have any questions, feel free to shoot me an email. I always say when I talk about deadlocks that if you run into a deadlock that you can't figure out or you're having trouble deciphering, excuse me, sorry, it's 9:30 p.m. here and I've had a long day. So if you run into a deadlock that you're having trouble figuring out, send me a copy of the deadlock graph and I'll be happy to take a look at it and offer suggestions. And I've presented this session a number of times. It was recorded at SQL Bits, and every now and then I get random emails from somebody that says, hey, I saw it in a video. I wasn't really there. Do you mind? And no, at least once or twice a week, I get a deadlock graph from somebody, and it doesn't take long to offer suggestions. I always like to say I've never found a deadlock I can't offer a solution to, but I run into a lot of DBAs and developers that don't like making changes required to eliminate them. So in most cases, we can come up with what's happening. Now, Paul gives away free 30-day trials of the 145 hours of content that SQL Skills has published on Pluralsight. If you send Paul an email, paul@sqlskills.com, and you put the subject line user group Pluralsight code, he will send you back a code that has no catches, no credit card. It's free for 30 days, and you get access to everything that SQL Skills has recorded for completely free. So if you're interested in that, feel free to shoot Paul an email. And I always start off with everything you need to know to prevent deadlocks. Use no lock on all select statements. That's it. So I want to thank you for coming to the user group. Right? How many people have actually seen this advice? This is something that's very pervasive on the MSDN forums. And for a number of years, I was one of the top answerers in both the database engine and across MSDN for forum questions. And some of the most common questions happen to be deadlock related. And this is a very common recommendation, is to just, usually one of the first few comments would be just use no lock, with no lock can't. And for certain conditions with select statements, yes, that might prevent the deadlock, but we have a dirty read that's happening. So I hate this advice because I don't know everything about your business. I don't know everything about your database, and I don't know if a dirty read is an acceptable thing. When I'm at the ATM or at the bank, I don't want the selects for my account balance to be no locked, where it gives me an incorrect balance, right? So this is dangerous advice because it doesn't address what actually is going on, and without knowing the system, it doesn't help. It also doesn't help when you have a writer-writer deadlock, where it's like an update and an update that deadlock against each other, because there's no such thing as a no-locked data modification unless you're using in-memory OLTP, and it has its own semantics for how it does it. But within the standard relational engine, every modification requires locks. So no lock doesn't help there. So what we're going to talk about is a quick review of locking inside of SQL Server, what a deadlock is, how do we collect deadlock graphs, and then what I call the anatomy of a deadlock, where we break them down and we actually read through deadlock graphs and we go through resolving deadlocks in different ways that we can resolve the most common types. So for terminology, when I say a transaction, what I'm talking about is any unit of work that gets performed inside of the database. And transactions are going to have locks associated with them, which are a synchronization mechanism on resources that protect them from changes amongst multiple concurrent transactions. Every lock has a lock mode, which is going to define the level of access that other transactions have while the resource is locked. Blocking is anytime a transaction requests a lock mode that conflicts with a currently held lock, and it has to wait for that lock to be released for it to gain access to the resource. And then a deadlock is when two transactions block each other trying to acquire locks on resources the other transaction holds in a conflicting mode. and you have a circular pattern of blocking that won't resolve itself. Now in SQL Server, locks are acquired at different levels of granularity. We have at the very lowest level, the row identifier or key lock, where it's either a single row in a heap or a single row in an index that gets locked. Above that, we have page level locks, where a single page in the database is locked. We have Hobbit or partition level locking in the B tree, object or table level locks. We have metadata locks. We have schema locks. There's locks all over the place. And as we go down this list, the amount of concurrent access we get to the data in the database decreases. But the higher up this list we are, the larger the number of locks we have to maintain are. So as a part of forming what's known as a lock hierarchy, the locks are acquired at multiple levels of granularity, and they're always done from the top down, starting at the table or object level down to the individual rows. And as I said, that forms what's known as a lock hierarchy. So if we look at it from a kind of a functional standpoint, if we have a data modification that executes and it's going to affect one row on the table, in this case a delete, the first thing we're going to do is acquire an intent exclusive lock at the table level. And that intent lock specifies that we have a lower level lock that's being held, and it protects somebody from gaining a full table level. In this case, a shared lock would be blocked by it. It can't do a select while there is a data modification if it has to escalate or run at the table level. Once we have that intent lock, we also get an intent exclusive lock on the page containing the row. And finally, we'll get an exclusive lock required for modifying the data. Now in the books online, and there's a bit.ly link on this slide, there's a huge lock compatibility matrix that defines every type of lock that can occur inside of the engine and whether it conflicts or won't, or is impossible with other lock types. This slide kind of lays out the most common locks that you're going to see when you're dealing with deadlocks. And those are intent shared, shared, update, intent exclusive, and exclusive. There's also shared with intent exclusive, but that's not a very common lock that I see or run into with deadlocks. But the other 5 lock modes that are on this slide are really important because they're usually the most common ones. And we'll talk about another type of lock mode later on in the session for serializable isolation range locks. So a deadlock is a condition when 2 or more processes are holding locks on resources and are each waiting for the other to release its locks to progress. And this isn't something specific to SQL Server. This happens. I've written deadlocks in C# and C++ code where you have multiple threads that are trying to synchronize access to different resources. And it's possible to write deadlocks in any language. It's the same kind of situation. So process A gains a lock on resource 1, process B gains a lock on resource 2. If process A then tries to lock resource 2, it's going to be blocked and have to wait. And then if process B tries to access resource 1, it's going to be blocked and have to wait. And we have a circular chain of blocking that will not resolve itself. So some misconceptions about deadlocks that I've heard over the years. The first one is that deadlocks are a bug in SQL Server. In most cases, that's not true. There is one specific type of deadlock that actually is considered a bug. It's called an intra-query parallelism deadlock. But otherwise, deadlocks occur because of the way objects are being accessed or because of execution plan choices that are made by the optimizer in some conditions. But they're not usually related to a bug. And there is a process in SQL Server for identifying and removing deadlocks. The next one, deadlocks cannot be prevented. I've never seen one that I can't eliminate entirely with some form of a change, but I've run into systems that can't be changed in the way that would be required. So we'll talk about other ways of handling deadlocks when you can't prevent them so that they're at least not problematic. Using no lock on select statements is the best way to prevent deadlocks from occurring. Adding covering indexes for every query type will prevent deadlocks from occurring. In certain conditions, that might be true, but there's a big overhead if you start trying to cover every single query with indexes. And in the worst case, I looked at a table that was 14 columns but had 42 non-clustered indexes. Every one of them prefixed with DTA underscore, because every time a deadlock popped up, they would run the query that was selected as the victim through the DTA, it would make an index change or a recommendation, and they would just create it. And that specific deadlock wouldn't occur again, but it would occur for a different set of columns or a different permutation. So that's not always the best solution either. And then the last one is that troubleshooting deadlocks is a complex task that requires an experienced developer or administrator. It really isn't. And when we go through reading deadlock graphs and how to look at the information, it'll make a whole lot more sense. Now, inside a SQL Server, the lock monitor thread is what's responsible for doing deadlock detection. And it will initiate a periodic search to identify and resolve any deadlocks that might exist in the system. The way that it does it is it walks the locking structures inside the engine, and anytime that it identifies that a task is blocked, it then does a recursive search to see if the blocking resource owner is also being blocked by this process, and if it does, that cyclic blocking forms what's known as a deadlock. Every time it detects a deadlock, it will decrease the search interval from a default of 5 seconds down to as fast as every 100 milliseconds based on the frequency that deadlocks continue to occur in the system. So on a very deadlock-prone environment, you'll see the lock monitor thread constantly working and doing deadlock searches. Now, the deadlock priority in SQL Server is a user set option that can be set at the session level to control the deadlock resolution behavior. The problem with this is that it's not possible to stop a user from setting deadlock priority, even with Resource Governor. And if somebody sets a higher deadlock priority, then it prevents their operation from being selected as a deadlock victim. The way that I usually use deadlock priority is I'll set deadlock priority low in a problematic piece of code, so that I know that that piece of code will always be selected as the deadlock victim. And then within that code, I'll put a try catch block oftentimes, so that if it does get a 1205 error, I'll check error number. If it's 1205, we'll retry the operation. Because the locking semantics inside of the engine are slightly different, it usually succeeds on a second or third attempt. So it's one way of doing defensive coding so that you don't end up bubbling problems up to end users. And in scenarios where you can't make schema modifications or whatever other changes are required, to stop a deadlock, you can at least keep it from being a problem. When it does occur, it'll retry it. Now, deadlock victim selection inside of the engine starts at the deadlock priority level. And if one of the sessions has a higher deadlock priority than the other one, the one with the lowest priority is always selected as the victim. If two sessions have the same deadlock priority, though, then the transaction that's the least expensive to roll back is who becomes the victim. And it's based on the number of log records that have been generated. Whoever has the least amount of transaction log is who becomes the deadlock victim. And this is why, in a lot of cases, select statements become deadlock victims, because there's nothing to roll back. They just have to release the locks and be killed. And when this occurs, a 1205 error is raised back to the client. Now, to collect deadlock graphs, PowerPoint just crashed. Give me 1 second. As I clicked through that, it died. So the way we go about collecting deadlock graphs is to there's a number of ways. The first way you can go is the legacy way, utilizing trace flags. And in SQL 2000, you had to use trace flag 1205 and 1204 and capture a server-side trace to identify what statements were participating in the deadlock and then troubleshoot further. In 2005, they introduced trace flag 1222. And what 1222 does is it writes the deadlock graph to the error log. You can also collect deadlocks with SQL Tracer Profiler, event notifications, and WMI. But starting in SQL 2012, you don't have to turn anything on. You don't have to configure anything else. It's already a part of the extended event session. And all deadlock graphs are going to be written not only to the ring buffer in memory, but also to the event file targets in the file system. So the most easy deadlock type to put together is what I call the reverse object order deadlock. And this is when two processes access tables in reverse order. Process A updates table A and requires an exclusive lock process B updates table B, and it gets an exclusive lock. And then process B needs to update table A, and that requires an exclusive lock, but it cannot acquire it because there's already an existing one. And then our deadlock is fully triggered when process A then tries to update table B with an exclusive lock. And this is the easiest one to demonstrate. It's the easiest one to create, but it's also the easiest one to fix because you just change the order of operations for the tables. And a lot of times where I run into this consulting, it's a condition, it's a case where one developer wrote one process at one point in time, and another developer wrote a new process that's just being introduced, and they're colliding on the order of access. And just changing the order of access for the tables resolves the issue. So what I'm going to do is I'm going to shift to my virtual machine, and we're going to set up deadlock captures. Where did... Nope.
Well, John, while you're doing that, anybody have any questions for John so far? John, can you hear me?
I can hear you.
Okay, yeah. Do you guys have any questions out there about deadlocking? Looks like no.
It looks like a no. So the first thing we're going to do is we're going to turn on trace flag 1222. And I always demonstrate this way. If we look at DBCC trace status, 1222 is a session level trace flag as well as being globally set. So if we turn it off like this and we look at our trace status, it's still globally set, which is the way that we want to do it with DBCC trace on 1222 -1. -1 is what sets it to be globally on across the entire system. So the next way we can go about it, I like to do this with remote DBA clients that we have. I use an event notification, which piggybacks on Service Broker. And the reason that I do that is with an event notification, when a deadlock graph occurs, it gets queued to a Service Broker service. And that service can then automatically process the message that holds that deadlock graph. And I usually generate these in MSDB because database mail exists in MSDB, and I can use an activation stored procedure to automatically send me a copy of the deadlock graph by email whenever they occur. So I get real-time notifications that a deadlock has occurred, and then I can go take an appropriate action related to that. So if we look at our sysserver event notifications catalog, we'll see that we have our capture deadlock event notification set up. I always include a demo for WMI, but I don't set it up because it affects my ability to run other demos for other classes, and I always forget to remove it. But there's a script here that will go through how you create agent alerts for WMI and an agent job that will process the text data from a WMI event and insert it into a table. WMI is built on top of event notifications as a platform, so I would typically just say use event notifications. But if you have external applications that need to consume events from WMI, you can get that from the engine as well.
I got a quick question. You do this mostly on-prem, I'm assuming. What about like a comparable solution for in the cloud? I guess just running on your VM, I'm assuming.
So in the cloud, Azure SQL Database, I can't answer the question for. I'd have to ask Tim, to be honest.
Yeah. Okay.
But if you run, like I have customers that run Amazon RDS for SQL Server, you can still access the system health event session by query to read the files. And as long as you're on RDS 2012 or higher, you can just get it right out of the system health event session.
Cool. Okay.
So what we're going to do is we're going to set up a deadlock demo database. And in that database, we're going to create a table called Table A. And Table A is going to have 1,000 rows inserted into it. We're going to create a clustered index on column 1 of Table A. And I always say I'm going to reorder the script, but I never end up saving it. And then we're going to create a non-clustered index on column 2. We're going to delete 2 rows from the table for one of the specific demos that I'll show in a few slides. We're going to create table B, add 1 row to table B. And the reason that table B only gets 1 row is that guarantees that when I do an update or a modification against table B, that's always selected as the deadlock victim. It has the least amount of log generation. And then 2 stored procedures, one that does a select with a key lookup, bookmark lookup operation, and then one that's updating table A as well. So with that created, let's look at our 2 reverse object order deadlocks. So what we're going to do is we're going to start a transaction and update table A, and it tells us to run the other window. So we're going to update table B, and then we're going to try and update table A. And when we do the update to table A, we have blocking. So to trigger the deadlock, we come back over here and tell it to update table B. It succeeded. And here we have our deadlock victim and a message that lets us know that the process was killed because of a deadlock on lock resources. So if we come over here and we execute sp read error log and scroll all the way to the bottom, and usually I cycle my error log before or restart the server before doing any demos on this, but we're going to grab it right here, deadlock list all the way down to the bottom. And what I'm going to do is I'm going to copy that and just paste it into a new window. Close this. We'll close this. No, we don't want to commit. And if we go to event notifications, we have to receive our deadlock graph off of the queue and then parse it out of the XML for the message body for the event notification. Here we have our deadlock graph. And the last way we're going to grab it is from extended events. So if we come down to this very last one, nope, it has not flushed yet. So one of the things with extended events, if you get a deadlock report, it can take up to 30 seconds for the deadlock to actually be output to the event files because it's an asynchronous process that actually does it. And here we have our deadlock graph now. So I always like to pull these up so that I can show this is our error log output from traceflag 1222. And this is our event notification output. And this is the same output that's going to be output by Trace, Profiler. If you look at them, they're identical. The only difference is that there's not XML tags and brackets around each of the pieces of information. But otherwise, it's exactly the same information. From extended events, we get a similar output. The only difference is this head area where in the original deadlock graph, it only allowed for 1 deadlock victim. Extended events supports multi-victim analysis, where it creates one graph that has all of the deadlock victims that have been killed in one operation in a single document. And it's the only place that you get multi-victim analysis. If you have a multi-victim deadlock occur and you're using traceflag 1222, you'll actually see 2 different SPIDs writing deadlock graph information interleaved in the error log. It's really hard to kind of figure out what happened. But this is the only other difference for extended events right here. So what I usually do, regardless of which format of deadlock graph I'm getting, is I come find the victim process ID and I do a replace. And I replace it with the word victim. And the reason I do that is it makes it easy for me to identify which process is the victim process. And the next thing I do is I come look at my resource list. So I can see that my victim owns an exclusive lock on table B and is requesting an update lock on table A. And then I can see that the other process owns an exclusive lock on table A and wants an update lock on table B. So it's pretty easy. This graph makes it pretty easy to understand what's happening, right? Obviously, this process made a change to table A and it's trying to change table B. And the victim has made a change to table B and is trying to change table A. So we can come back up here and expand our processes and take a look. And I can see here, the victim has update table B, update table A. And then my other process, I have update table B, but I don't have anything that points me to table A. And this is where troubleshooting deadlocks can become a little challenging at times. The locks that are being held might not have anything to do with the current statement that's executed or that's in the execution stack. So you might have to, a lot of times it's easier with stored procedure code because it tells you what the entry point was. And you can go read through the stored procedure code and see what else is happening before the section that actually was caught in the deadlock. But don't forget about other things like trigger logic that might be happening. There's a lot of other things. And sometimes when I get a deadlock graph, I'll ask for additional information like, can you send me the table DDL? Are there any triggers? What indexes are there? But you can see the process that succeeded, the amount of log used, 364K versus 264 for our victim. So it followed the appropriate priority and then log usage, and that's what determined the deadlock victim. So this would be a case where I would need to come back and look, but its reverse object order is definitely played out. And I would look for what is this process doing to table A first, and can we change the order around? Now, the next deadlock that I'll go through, and this I think is one of the most common types, is the bookmark lookup or key lookup deadlock. And what you'll see with this is in the execution plan, you'll have a key lookup operator. And what happens, it's purely timing based, but we have a process that's going to insert, update, delete. It's doing some kind of a modification. And that's going to acquire an exclusive lock on the clustered index. And at the same time, we have a select start that is highly selective and can leverage a non-clustered index, but the non-clustered index doesn't cover the query. So for that to finish processing the query, it has to do a key lookup, which also requires a shared lock back to the heap or clustered index. And that is blocked by what is an exclusive lock during the other process's execution. Well, if we change something in our base table, our heap or clustered index, the next thing we have to do is we have to modify the non-clustered index entries, and that's going to require an exclusive lock, and this is where we end up in our deadlock condition. And I always like to joke, this is the SharePoint deadlock. If you've ever managed a SharePoint solution, this is the deadlock that happens inside of SharePoint during index search crawls all the time. So since the select statement has no log generated, it's going to roll back, release its locks, and the other process will complete. So let's come back over here, close out these windows. So we're going to run in a tight loop a select statement. And if we pull this up, let's just grab our estimated execution plan. You'll see the key lookup here. So we're going to run this. And then in another window, we're going to start a process that just updates the table. And we'll see almost immediately we have a deadlock that's occurred. So I'm going to go grab from 4 off of event notifications, our deadlock graph. Come up here, replace it with the word victim. Shrink these up, and let's look at our resource list. So within our resource list, we'll see that our victim process owns a shared lock on table A, and it's requesting a shared lock on table A. So when I see the same table, almost always I think of this exact deadlock. I look for, is there a bookmark lookup when it's only one object involved, but there's two indexes on the same object. So we're going from a non-clustered index to a clustered index here. And we have a shared lock, we're requesting a shared lock, and we have an exclusive and an exclusive. So usually what I'll do when I see this type of condition in the resources, it's a marker. It's a common pattern that I see. I'll come back up here and look at what was this running. So I can see that it's doing this loop. It's inside of the bookmark lookup select store procedure. So I can grab this, take it to another window, paste it in, grab the execution plan, and start looking at what would happen. And there's a number of ways that we can prevent this type of deadlock. The first way would be we could use no lock, right? If we with no lock this, will it stop the deadlock? Absolutely. That might not be the correct thing for your environment though, right? So other things that we could do, we could leverage snapshot isolation maybe, right? Recommitted snapshot isolation. We could create a non-clustered index that's covering. We could modify our existing index. So there's a lot of options for how we might eliminate this deadlock altogether and make it so that we don't have a condition where a deadlock could occur. Which one's the right fit depends on the environment. Leveraging recommitted snapshot isolation has row version overhead, and will introduce row versioning in TempDB. That might not be appropriate for every situation, but you might have a system where you can't make changes to the indexing easily, or it's not allowed because of a third-party vendor app. You can't make code changes. So whatever limitations you have, it's kind of weeding out or looking for what are the solutions that eliminate this. In this case, most of the time, just a non-clustered index is the best way to go about troubleshooting it. So intra-query parallelism deadlocks are the bug that exists inside a SQL Server. And it's a deadlock between parallel threads, usually on a merging exchange within the same session that's executing in parallelism. It's generally a bug in the optimization process, and a fix for it might cause query plan regressions, or it might be too risky for them to even attempt to fix. Usually when customers have run into these, the way you identify it is every process in the graph has the same SPID, and the deadlock resources will be on exchange event resources only. If you have more than one SPID across processes, you have a deadlock that involves parallelism maybe, but it's not an intra-query parallel deadlock, and you just want to troubleshoot it like you would any other deadlock. For certain customer conditions, the way you resolve these is introduce something that affects the way the plan is generated. A lot of times just tuning the query will eliminate the intra-query parallelism deadlock because you get a different execution plan. But in some cases, you might have to change database indexes, and in other cases, you might just need to use option max stop and reduce parallelism for the query. I usually say cut it in half, get down to 2, and if you still run into the intra-query parallel deadlock, go to max stop 1, and that's the only workaround that you have to prevent the deadlock from occurring. So ways that you can go about resolving deadlocks, changing indexing to cover queries is possible. Enabling recommitted snapshot isolation, so writers don't block readers, readers don't block writers. Changing your isolation level potentially, or in some cases even using locking hints to force specific lock types to prevent conversion of locks under certain isolation levels from leading to deadlocks. But I always say do defensive coding. I like to catch deadlock errors, and like I said earlier, if a piece of code is potentially deadlock prone and you can't eliminate the deadlocks, deadlock priority of low for your session and a try catch block will at least let you control what's going to be selected as victim and allow you to do the next thing that I would do, which is retry, and wrap custom retry logic around the operation so that it will retry after a deadlock occurs, because the locking scenario that led to the deadlock is usually very short duration and in milliseconds, and it's going to not exist when the transaction gets resubmitted. So it will succeed the second time through. And if you do this, just make sure that you do some kind of logging that the deadlock has occurred so that you can eventually move to a point of prevention in the future. So are there any questions about anything that I've talked about? And as a part of the demos, there is an additional set of handling deadlocks that has a retry logic block. And this is, I use this block of code.
Hey, someone has a question.
Sure.
Yeah, are you going to cover optimistic locking as part of this?
Can you repeat that question?
Are you going to cover optimistic blocking? I believe.
What do you mean by that?
What do you mean by optimistic blocking?
Where you, well, I know Oracle has it, and I thought SQL Server has it too, where they version the row instead of just putting a lock on it.
Maybe we can have him send in an email what he's asking. Kind of, you said, you know, Oracle has where you're merging rows. You said
Versioning the row. Versioning.
Oh, you're versioning the row. Okay. And then when you're versioning the row, it locks it. Is that what you're saying? You get a deadlock.
Well, it allows the readers to go through.
So I think what he's asking about is read committed snapshot isolation, RCSI, which readers won't block writers and writers won't block readers because it's leveraging row versioning in TempDB to allow the reader a consistent state of the data for where its transaction started. Is that what you're asking about?
I guess, yeah. I don't have any experience with it in SQL Server, so that's why I was asking.
So recommitted snapshot isolation as a topic is a very big one. It was introduced in SQL 2005, and Kimberly wrote a white paper that compares it to what the Oracle equivalent behavior is. That goes through all the things that you would want to verify with your application to make sure that it's not giving you incorrect results because it's leveraging versioning or unexpected results. So I can include a link to that white paper. It would explain it way better than I can.
Yeah.
With all the semantics. And like, I don't know if you guys know Kimberly, but she doesn't like, when she writes something, she doesn't just gloss over it. Like she goes down every rabbit hole and is very meticulous about making sure she's covered something entirely. So that, like, usually I would just, when I recommend recommitted snapshot isolation or snapshot isolation to a customer as a possible fix, I usually send the link to that white paper and say, please read this and see if it's a fit for your environment. Because this might be a solution to the problem that you're running into.
Cool.
Does that answer the question?
Yes, thank you.
Oh, now I have another one.
I have a developer that I guess inherited AX, and occasionally we'll get locking and some locking sessions and whatnot, and I can give them the information from the error log, this particular item, the tables and the accounts and the queries that is actually causing the deadlocks, but he doesn't know the code well enough apparently to say what comes before that. So he wants to install Dynaperf and turn that on full time and introduce all kinds of trace flags.
Can you guys repeat that question closer to the mic?
Yeah,
because I'm only getting pieces of it.
Can you even bring the computer over to him, or he can come over and ask it?
How's this?
Little
That's
bit
better.
better.
Okay, basically, I have a developer that basically inherited an AX system, AX12, and he doesn't know the code that well. And I can give him this information from the graph. I got the trace flag right to the error logs, and I can give him the queries. I can give him the the user accounts. I can give him the tables and whatnot. But he doesn't know the code well enough to say exactly where in the code that is lying. If that makes sense.
Mm-hmm. I've heard that plenty of times.
So how do I help him locate? I mean, he basically wants to start, more or less, he wants to turn on debug on the entire system to find it.
So he's not using stored procedures. He's probably using just regular SQL queries from his application.
Well, they're all ad hocs. AX is primarily all ad hocs.
Depending on the type of deadlock it is, a lot of times within AX, they have a way of creating indexes through the UI that are supported.
Right.
And, I would have to see the graph to know if just an indexing change would fix it. That would be the first route that I would go, is that an indexing change probably would cover, it's probably more related to the key lookup or bookmark lookup scenario.
Okay. Because it usually happens when it's doing a select.
That's always going to be a key lookup, I'm going to guess.
I'm sorry?
I would venture a bet. I mean, sometimes a select where it has a lot of joins, it can
Right.
deadlock because it's changing the
So-
order of access, and you
Right.
might have to hint it to force it to access tables in a specific order. But most of the time, it's a key lookup,
Okay.
which is exactly what I demonstrated. Right? It's going to be,
Right.
if you look at the graph, it's a non-clustered index and a clustered index on the same table. And if you go grab the plan for that statement that ran, you should see the key lookup, and that key lookup operator.
It's actually it's the first deadlock thing you actually showed, not the bookmark one.
Where it's changing tables.
Yeah, where it has where one system is accessing one table and another is accessing another table, and whatnot.
Unfortunately, with it being AX, you might. The easiest thing would probably be to post that question to an AX forum. Is, how do I find where this query came from?
Okay.
Or
Just-
the
what I
other thing you
understand-
could do, and I've had to have customers do this with not AX but with GP, which is another Dynamics product. On a dev server, start up a server side or start up a profile or trace, and have them start using the application till you find the query,
Yeah,
and then they know where they did something that created that query.
it's not reproducible. He doesn't know what is causing it, and I don't know the application. I know SQL, but I don't know the application. And then in addition to that, they have the whole update processes covered under TFS.
Yeah, I can't help you there, unfortunately. That's one of those that if you can't change it, then I can't offer any suggestion there other than I mean I've spent hours with customers watching profiler screens until we figured out where a piece of code came from.
Right, and that's what I'm doing.
And that there's no good way to put it. That stinks. It's not fun, but sometimes it's the only way to figure it out if they don't know where the application is generating the code.
Yeah, and the other thing I'm basically doing is I'm going through all the processes and query plans and whatnot and capturing everything that hits those two tables and try to find something similar.
Yeah, the only other thing I could tell you to do would be to run an extended event session or a server-side trace that is capturing a lot of events. And when the deadlock occurs, you can walk backwards on those SPIDs and figure it out.
Yeah.
But you're going to have to capture like every RPC command, every statement completed, every
Yeah,
procedure completed event. Like there's
I know. And the loads
basically in extended events, it would be the query detail tracking template is what you're going to want to run. And you have to collect a bulk load of data
how much
so
of a
that
load?
when you get the deadlock, you can go backwards and figure it out. And that's the way you had to do it in SQL 2000 timeframe.
How much of a load does that put on there? Is it going to be the same like Profiler when you turn all the flag or turn all the?
Don't use Profiler. You need to script it as a server-side trace if you're going to use
Right,
trace.
No, I'm asking.
Extended events to a file. If the server was 100% saturated, it should be about a 9% load drop. It's
Okay.
small, but
Okay.
on a server that's not saturated, usually you won't know it's there. But it has to be writing to a file server side, whether it's extended events or trace. It needs to be writing to a file server side.
Yeah. Okay. No,
I mean, you
I
just go back.
definitely
You could set it up for file rollover, and when the deadlock occurs, this would be a good place to have like an event notification. So when it occurs, you get a database mail message. You go grab the files, and then you start digging through what occurred.
Yeah. Okay. Yeah, I definitely don't want to use Profiler.
Because Profiler will take 90% of that workload away.
Yeah.
It's just the way that it works row set. So,
Yeah, I've seen it take down systems before, so.
but that's the only other thing I could recommend but then even if you have that piece of code, they're going to have to match it to something in the application to fix it.
Right.
So,
Okay. Thank you.
sure. Any other questions?
I was curious about seeing that resulting deadlock. Hey, you mind showing that call-me deadlock frame real quick again? You went by that kind of quickly, and I just wanted to take another quick look at that, if you don't mind, please.
We can't
Is
hear
this
him
what
now.
you're asking to see?
Right, yeah, I was just making sure. I kind of saw the same.
So, some key takeaways for this session. First, most deadlocks aren't a bug in SQL Server. Second, don't blindly use no lock on select statements or add covering indexes. Look at the root of the deadlock before making any changes, and look at the system and identify what's going to be the best overall solution for the system. And whenever possible, leverage defensive coding in T-SQL with try-catch blocks so that you can handle the deadlock and retry whatever the victim transaction is. And remember, if you don't know, if the victims are constantly changing, but the process that succeeds is consistent across multiple deadlock graphs, sometimes taking the process that succeeds and telling it to become the deadlock victim with the deadlock priority low and resubmitting the operation for retry can be really beneficial. Right? You might have a piece of code that's very prone to deadlocking against 4 or 5 other different types of processes. But if that one piece of code is the common link, resubmitting that for deadlock retry is a really easy way to make sure that you get control over what's happening. Now, there are a lot of resources for deadlock analysis. The best one is Bart Duncan's blog at Microsoft. It's where I learned everything I know about deadlocks. And deadlock troubleshooting originally for SQL 2000 and then again for 2005 when they changed the deadlock graph. I've written a number of deadlock posts on SQL blog and SQL skills, articles in SQL Server Central, and I have a 2.5-hour Pluralsight course that goes through a lot more demonstrations of specific types of deadlocks, how they get triggered, how to identify them, and how to troubleshoot them as well. So if there's no other questions, I'd like to thank you.
One more question.
Yeah, I got one more question.
Go ahead.
Sorry, I know it's late for you and you want to go to bed. And,
No, it's fine. Go ahead.
and maybe you don't need to necessarily answer this, but if you can point me in the direction of examples on how to resubmit that concept you were talking about, let's resubmit the transaction or whatever. Where would I go to see how to do that kind of thing?
It's in the demos that I'll upload, but this is the try catch block with retry set to 4. So this is how you would do it in T-SQL. I usually just literally I grab this and I change this block of code right here. I comment out this select, and then if I'm on 2012 or higher, I do throw here instead of raise error. But otherwise, this is exactly the same block of code I implement in customer environments. If you want to see it from a C# code perspective, it's right here exactly the same way. And both of these come in the demos. So if you wanted to wrap your C# or ASP.NET code.
So yes, you're basically just making a loop and doing everything inside that loop, and you're saying, "We'll try this loop up to 4 times and break out if it succeeds." Okay. Cool. Thank you.
I have to redo my license there. Yeah, so I'm just doing it in the loop, and every time that I retry, I decrement the loop. And I do the same thing in T-SQL. It's every time we retry, we decrement by 1.
Yep.
And when it's 0, it fails. It actually fails.
With the correct error, right? Okay, cool.
Yes. So that usually less than 10 times. 10 is the highest retry count I've ever used. Usually it's the first or second retry. It hits and it's done.
Sean, do you have any more questions for Jonathan?
More questions? No.
Thank you.
Thanks.
Yep. No problem. And I'll let you know, or I'll just send you the demos and the PDF of the deck.
Oh yeah, definitely. We'll put that either visible on our meetup or our past site. And I'd like to thank you, Jonathan, for taking your time. And I know it's late there, and I think Tim got off early because we were at 4:30, starting 4:30 at the one he did. But no, we appreciate it. I know you have a lot of you have a lot of work going on, so it definitely is for you to take your time and share this with us and give us your time. Like, this is great. We appreciate that. We're gonna send you an Amazon gift card for what you did tonight. It's great. We appreciate it, and like I say in the email, tell Paul and Kim that we appreciate all that they've done for us as a user group and allowing you guys to do this for us. It really means a lot to the group, and hopefully next year we'll have you back and we can definitely
I don't see us stopping doing it. So it's a nice way to give back to the community and reach out. So
cool. Are you going to be at Dev Connections, or are you going to be, or is it Dev Connections? Tim was saying,
I'll be at SQL Intersection.
Your SQL Intersection. Okay, cool. Yeah, I'm going to be at PASS Summit.
I was already locked into that before PASS did their speaker announcement. So I'll be there. Aaron will be at PASS. I think Glenn will be at PASS.
Mm-hmm.
So, all right.
Cool, man.
Well, nothing else. You guys have a good evening, and I will. I'm sure I'll present again at some point.
Thanks again.
Yep, no problem. Bye.
Okay, everybody.